graders, happy weekend. I hope you're enjoying the sunshine. Can you say hi, Georgia? Oh. We are getting into lesson 16. We're still redhead. But we're going to continue finding fractions of fractions. Yo, you want to show them your monster jammies? Cookie Monster jammies. He says cookies make me sleep. Yeah, he's got Cookie Monster jammies. They're funny. He's got big belly. Did you have chocolate? You got a really big belly. Yeah, they're stretchy. We're going to continue finding fractions of fractions. and it's going to be great, and we're going to start working on like some more complex problems, but you're totally ready for it. Yeah, George, do you think they're ready for it? Okay, can you say bye-bye, George? Bye-bye. Bye-bye. Say you're doing a great job, guys. Keep up the great work. Oh, you're going to give a kiss. Oh, that's sweet. Okay, let's take a look at some problems. Okay, buddies, we're in lesson 16. I just spent... how long did that take, honey, figuring out that problem?
10 minutes. I
just spent about 10 minutes trying to figure out the answer to this problem. I'm 38. I have a college degree. I double minored in math and science with elementary ed major. I'm a pretty smart lady. I know my gifts. This problem, woof, is tricky, but there is a way to see through it. Let's just take it really slow. And while I'm doing the problem, please be very critical because I know there's an easier way to do this problem. So if you can come to me tomorrow with an easier way to solve this problem, game on. I will give you my undying devotion and respect. So let's walk through this problem and let's just take it one step at a time because it is a beefy one. Okay, so this is all happening at Cascade Ridge. Cascade Ridge is holding a school-wide election to choose, we'll just say like a new school color because we already have school colors. 5/8 of the votes were for blue. 5/9 of the remaining votes were for green, and the remaining 48 votes were for red. First question we need to answer, how many votes were for blue? And then we'll by the time we have this all set up, then the amount of votes cast for green will reveal itself. Okay, so let's just look at this all of the votes as a tape diagram. This whole rectangle represents all of the votes. And we're going to start with blue. So we're going to go ahead and chop this into 8 equal parts. 1, 2, 3, 4, 5, 6, 7. I really want this to look crystal clear, so I'm actually going to get rid of that little leftover. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. The problem tells us that 5/8. 1, 2, 3, 4, 5/8. 5/8. And we're really going to use color here because I think that's a really good way to organize the information. Where's my color wheel? I don't know where my color wheel went. I lost it in my frantic search to solve this problem. Mr. Calamaris gets to watch Minions with the boys, and I'm here figuring out how many votes were cast for a fictional school color voting election. Okay, so 5/8 here, you guys, of the votes were blue. Then we have this leftover chunk. We have these 3/8 left. I'm going to go ahead and temporarily break off these 3/8, and I'm going to rewrite these 3/8 down here because this word here is so important. 5/9 of the remaining. That means the remaining votes after blue. So 5/8 is dedicated to blue, but then we have this remaining chunk. In this remaining chunk, you guys can see that this remaining chunk is 3/9. I'm sorry, 3/8, right? 1, 2, 3 at a total of 8. 8 total squares because we chopped this into 8. So 5/9 of the remaining again, 3/9, you guys, were for green. And this is really such a good problem. And the remaining 48 votes were for red. Okay, so I'm gonna break the remaining off, and then I'm going to do some work on that remaining chunk down here. I'm going to now slice the remaining after I temporarily broke off the chunk. I'm going to slice it into 9 equal pieces because we are told that 5/9 of the remaining, this remaining got broken off down here, and don't worry, we'll patch it back up here in a second. So we're going to chop this into 9 equal pieces because we're told here that 5/9 of the remaining were blah, blah, blah. So right now, let's just chop this into 9 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. So what are we told? We're told that 5/9 of the remaining were for green. No problem. I'm going to color that in because I feel like that's really the best way to organize this problem and see all of our variables. We have a lot of them in this problem. Okay, so we have 5/9, you guys here, dedicated to green. I'm just going to label that so it's very clear. 5/9 dedicated to green. Okay, and then you guys, this is so interesting. The remaining 48 were for red. Okay, so I'm going to go ahead and color that in red. So the remaining, hey, Georgie. Georgie's really excited by this problem. Oh, sorry, that was him headbutting my pen. So we have 4. You can see 1, 2, 3, 4 slices left. Thanks, George. You helping? Mama's almost done, baby. I know. I've been working on this for a long time. Yeah, you gonna help? Okay. So we colored in the remaining 1, 2, 3, 4 chunks. 4 chunks looks like, you guys can see that's 4/9. And that makes sense because 5/9 plus 4/9 equals 9/9. That's our whole. So we have 5/9 are green. Yeah, Georgie, don't press that button. 4/9 are red. But here we've been given a critical piece of information. We're told that there were 48 votes. So what we're looking at is 40, oops, I zoomed in too much. What we're looking at, you guys, is 48 spread across 1, 2, 3, 4 boxes. If 48 is spread across 4 boxes evenly, what number is inside each box? Well, you can do long, oh, George, please don't do that, honey. I'm almost done, Georgie. Okay. I know, it's really fun. Okay, if you don't know that right away, Georgie, you cannot do that, honey. 48 divided by 4. 4 goes into 4 one time. 1 times 4 is 4. We have nothing left when we take 4 from 4. Bring down our 8. Think about how many 4s go into 8, and that is 2. 2 times 4 is 8. We have nothing left. 48, I know a lot of you are able to do that in your head or you have that memorized, is 12. So what that means for us, you guys, is that a 12 lives inside of each of these boxes across red, because 12, 4 12s equal 48. Georgie. So if we have 12 inside each of the boxes in the red section, we also have 12 inside each of the boxes in the green section. Yeah, Georgie. So let's think about what that means. Do you remember breaking off? Yes, George. Yes, George. Georgie, you cannot touch those buttons. Sorry, guys. Georgie, do you want to go watch movies with Daddy? Do you want to go have a dinosaur party? Bring the dinosaur to Daddy. George, bring the dinosaur to Daddy. Get him. Get him. Okay. I'm back, guys. Sorry, I had a little visitor. Okay, you guys. So what we've found is that when this chunk that we broke off is sliced into 9 equal pieces, there's a 12 that lives inside each of the boxes. So essentially, what does our whole chunk represent? Well, it's 12 copied 9 times. 12 times 9 is, 9 times 2 is 18, carry the 1, 9 times 1 is 9 plus 1 is 10. So what we've ultimately found, you guys, is that this whole chunk, this remaining piece, is 108. And now, if we take this amazing information and we bring it back up here, what we can see now is that 108 is spread evenly across 3 boxes. Now that we can place the information that we found down here and put it back into our main model, we need to figure out what number lives inside of each of these boxes. It's going to be a different number than what we saw inside of each of these boxes, because when we broke off the remaining, divided it by by 9 equal slices, we found that 12 lived inside each box. Now we're going to slap it back up here, and we're looking at 108 spread evenly across 3 boxes. So let's figure out what number lives inside of each of these 3 boxes. We can do that super easily by just doing some long division. Let's look at how many 3's fit into 10 with some left over. 3. 3 times 3 is 9. Difference between those two numbers is 1. Bring down our 8. We're looking at 3 into 18, 6. 6 times 3 is 18. We have no difference. Fabulous. So what that shows us, you guys, when 108 is spread evenly across 3 boxes, we have 36 that lives inside of all of the boxes, because in these tape diagrams, everything is cut into even slices. So our question is, how many votes were for blue? Well, we have 5 blue boxes, and inside, it was 5/8, recall. Inside of each box lives a 36. So let's figure out what 36 times 5 is. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 8. Good grief. Final answer for blue, you guys, is 180. My goodness. And then how many votes were for green? Well, we already have that answer. We have 1, 2, 3, 4, 5 boxes. Remember, it was 5/9 of what was left over. 5 times 12. Remember, 12 lives inside of each box. Inside of each box. So for that one, you guys, we're looking at 12 times 5. 5 times 2 is 10. We're going to look at 5 times 1, which is 5, and then add 1, 60. Oh my gosh. That was a really, really big problem. I know that there's a lot going on here, you guys. This is going to be the only problem that I do. I want you to feel comfortable coming into class tomorrow solving a problem like this. So think about your understanding right now. Think about where, if you were kind of on board for the first part, and then when I cracked this remainder off and dropped it down here, if that got confusing, please watch this part again. This, you guys, as I told you, this took me a while to figure out how to solve. So I'm not expecting this to make complete sense the first time you watch this video. So maybe think about it for a little bit and then come back in about 15 minutes or so and watch this again. Maybe you'll watch it 3 times. Repetition, the more you practice something, the better you are at it. The more you watch me walk through this video, the easier it is to understand. So the first time I can understand you're probably cross-eyed and smoke may be coming out of your ears. That's good. That's normal. That means it's working. The second time, maybe your eyes aren't so crossed and you have a little less smoke coming out of your ears, and then you watch it for the 3rd time, and then you're able to actually predict the next steps, and then maybe things are falling into place. But it's just repetition, you guys. Repetition, repetition, repetition. And perseverance. I persevered. I could have chosen a new problem, and I could have let my ego get in the way, and I could have said, oh, I'm 38. I should be able to get this on the first shot. I didn't. I did not get the correct answer the first time, and I'm okay with that because math is tricky, and we just have to keep trying. But love you guys. Hope you enjoy the sunshine. Hope some of you caught some... I was going to call them gremlins. No, not gremlins. Leprechauns in your leprechaun traps. And the secret word, you guys, for today is perseverance. Because that's what I have every single day. And that's what you guys continue to show me that you have as we tackle these big problems. See you in the morning.